Crocodile paradox. Imagine this. A crocodile kidnaps a child and tells the parent, "I will return your child only if you correctly predict what I will do next." The parent thinks carefully and says, "You will not return my child." Now here's the problem. If the crocodile does return the child, then the parent's prediction was wrong. So the crocodile should not return the child. But if the crocodile does not return the child, then the parent's prediction was right. So the crocodile should return the child. This creates a never-ending loop with no clear solution. The crocodile is stuck and can't decide what to do without breaking his own rule. Final thoughts. The crocodile paradox shows how sometimes simple promises can trap us in impossible situations. It reminds us how tricky logic can get when predictions about future actions are involved, and how language can create puzzles even when intentions seem straightforward. Like puzzles and paradoxes, hit that like and drop a subscribe. 2. Friendship paradox. Have you ever felt like all your friends have more friends than you do? Sounds weird, right? But it turns out there's a real paradox behind it, called the friendship paradox. Here's how it works. When you look at your friends, most of them actually do have more friends than you on average. How is that possible? It's because people with lots of friends show up in other people's friend lists way more often than people with few friends. Imagine someone who's super popular with 100 friends. They're counted 100 times when you look at others' friend groups, while someone with only 2 friends is counted just twice. So when you average it out, popular people pull the average up. That makes it seem like your friends have more friends than you, even if that's not true for every individual case. Final thoughts. The friendship paradox teaches us something surprising about social networks, how our perspective can be skewed by the way connections are counted. It's a cool reminder that sometimes what we see isn't the full picture, and our social circles might be trickier than they seem. Send this to someone who thinks they're too smart. Let's see how they do. 3. Value paradox. Imagine you find a diamond ring in the street. You know it's valuable, but how much is it really worth? Now think about water. It's essential for life, but it's usually cheap. This puzzle is called the value paradox, or the paradox of value. Back in the day, economists noticed something strange. Things like water, which we desperately need, often cost less than diamonds, which aren't essential. Why? Because value isn't just about usefulness. It's also about scarcity and demand. Water is everywhere, so its price is low even though it's vital. Diamonds are rare and desired for beauty and status, so their price is high. Final thoughts. The value paradox shows us that price and value don't always match up. What's priceless to us might cost little, and what's shiny and rare might cost a fortune. It's a neat reminder that economics mixes both practical needs and human desires. 4th Sorite's paradox. Imagine you have a big pile of sand. You take away one grain. Is it still a pile? Of course. Now take away another grain. Still a pile? Probably yes. But if you keep doing this, grain by grain, eventually you'll have just one grain left, which is clearly not a pile anymore. So when does it stop being a pile? This is the Sorite's paradox, sometimes called the paradox of the heap. It shows how vague concepts, like pile or heap, can create confusing problems when we try to apply exact logic to them. Final thoughts. The Sorite's paradox reminds us that some things in life don't have clear boundaries. It challenges how we define concepts that are fuzzy or gradual, and it pushes us to think about how language shapes what we understand as true or false. 5th, Fermi paradox. Picture this. The universe is unbelievably huge, with billions of stars and even more planets. Many of those planets could have life. So where is everyone? This question is the heart of the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" With so many chances for intelligent life to exist, and the universe being billions of years old, it seems like we should have already met aliens. But so far, we haven't found any clear evidence. There are lots of possible answers. Maybe intelligent life is extremely rare. Maybe advanced civilizations destroy themselves. or maybe they're deliberately hiding from us. Final thoughts. The Fermi paradox challenges us to think about our place in the cosmos. It's a mystery that keeps scientists, philosophers, and dreamers wondering if we're truly alone or just waiting for a cosmic hello. 6. Barber paradox. Imagine a small town with a barber who shaves everyone who does not shave themselves. Now here's the tricky question. Does the barber shave himself? If he does shave himself, then according to the rule, he should not shave himself, because he only shaves those who don't shave themselves. But if he does not shave himself, then he should shave himself, because he shaves everyone who doesn't shave themselves. This creates a logical contradiction. The barber can't shave himself and also can't not shave himself without breaking the rule. This puzzle was created by the famous mathematician Bertrand Russell to show problems in naive set theory, when rules refer back to themselves and cause paradoxes. Final thoughts. The barber paradox shows us how self-reference can lead to impossible situations. It's a fun but deep reminder that sometimes simple rules can hide tricky problems when they loop back on themselves. Love paradoxes? Hit the like button and follow for more mindbenders. 7. Bootstrap paradox. Imagine a time traveler who goes back in time and gives a famous scientist a book about advanced technology. The scientist studies the book, publishes it, and inspires the technology that leads to the creation of that very same book. Here's the puzzle. Where did the book originally come from? This is the bootstrap paradox, a time travel paradox where an object or information exists without a clear point of origin, caught in a loop. It's like a story with no beginning. The effect causes the cause, which causes the effect, all tangled up in time. Final thoughts. The bootstrap paradox challenges our ideas about cause and effect and makes us question how time really works. It's a fascinating mind-bender that shows how time travel stories can twist reality in puzzling ways. 8. Grandfather paradox. Imagine you invent a time machine and decide to travel back in time. You go back to before your grandfather had children and accidentally prevent him from meeting your grandmother. Now, if your grandfather never meets your grandmother, one of your parents is never born, which means you would never be born either. But if you were never born, then how could you have traveled back in time to stop your grandfather in the first place? This is the grandfather paradox, a classic time travel puzzle that shows how changing the past could create logical contradictions. Final thoughts. The grandfather paradox highlights the puzzling challenges of time travel and cause and effect. It forces us to rethink how the past, present, and future might be connected, and whether changing history is truly possible. 9. Twin paradox. Imagine two twins. One stays on Earth, while the other hops on a spaceship and travels near the speed of light for several years before coming back. According to Einstein's theory of relativity, time slows down for the traveling twin. So when the space-traveling twin returns, they are younger than the twin who stayed on Earth. This strange effect is called the twin paradox. It seems weird because both twins can see the other as moving, but the traveling twin's journey and acceleration cause time to pass differently for them. Final thoughts. The twin paradox shows us how time isn't as absolute as we think. It challenges our everyday sense of reality and opens the door to the incredible, mind-bending world of physics and space. If this made your brain hurt in the best way, like and subscribe for more. 10. Card paradox. Imagine you have a card with a statement on one side. The statement on the other side of this card is true. Flip the card and it says, the statement on the other side of this card is false. Now, is the statement on the first side true or false? If the first side is true, then the second side must be true, but the second side says it's false. If the first side is false, then the second side is false, which means the first side is true. This creates a loop with no clear answer, making it impossible to say if either statement is true or false. This is the card paradox, a version of the famous liar paradox, showing how self-referential statements can create impossible situations in logic. Final thoughts. The card paradox teaches us how tricky language and truth can be when statements talk about themselves. It's a clever puzzle that keeps philosophers and logicians fascinated about the limits of truth and meaning.